Everybody, teacher Chen over here. Welcome to WA2 revision for Sec 4E Math. Okay. For those who like the worksheet, don't worry, I'll resend it later on. Okay. Now, just a little bit of things to share with you guys. I teach lower Sec, E Math, and A Math. Now, this time round, I'm also teaching J1 lah. Okay, coming soon. I mean, if you have anyone who want to join, can come and find me lah. But most of my classes are at Tampines. I teach at Kovan on Sundays. The rest of the days I yes, who's that? Can you type in the chat instead of unmuting yourself? Thank you. Okay, now credentials, same old thing. I've done my honors, my degree in mathematical sciences. Math nerd over here. Got 4 point something for my GPA lah. Okay lah, did very well lah. But the main thing is that I have done quite a bit of things with regards to maths. Exposed myself in a lot of areas. So I roughly know, I mean, yes, I do higher level math, but at the same time, I also pick into those lower level math, the kind of common math that all of us will have to know how to do. So I will know some of the weaknesses that you guys will have. Now, fun fact, every WA I share a fun fact, but I can't be using the same old fun fact, right? So I will share about this time round, I'll just share with everybody. I walked 32 kilometers with almost 30 kg upload. I think that was a 10-hour walk. It was very shag. Yeah. So just quickly share with you guys, we have a few branches across different places: Tampines, Marine Parade, Kovan, Bishan, Novena, Bukit Timah, and Jurong East. Okay. I think this part I will skip. Okay. I want to mainly for today, I just want to focus on the content because I have quite a little bit of things to share with all of you. So I will be going straight into content. I will reshare the documents for those who don't actually have it. There's 33 of you. I know some of you guys just joined. So let me share the screen first. Let me resend the document to all of you. Okay, just give me a while. Okay, for those who just joined, please download the copy. Okay, I'll just send it to you guys. Can? Okay, so today, right, the main thing we are covering today is on matrices, algebra, some basic algebra stuff lah, and trigonometry. Okay, trigonometry as in Sec 3 trigonometry. Okay. So the learning objective, okay, I think very important. You guys know what you're here for. There's as I said, there's a lot of things I'm going to cover today. So main thing is I have matrices. I will be going through one question on that, and then I will be spending more time. I will be spending a little bit of time on your graphs, your functions, and even proportions. Okay. I will also go through one complete square lah. Okay, and then the other aspect of it is on trigonometry. Okay, so I'll be going through, I think, one question. I can't remember. One question, yes. I believe one question. Okay. So in the span of 1.5 hours. So this is actually going to be very rushed. I just tell you first. So I will be speeding up quite a bit, but hopefully I will be able to capture the main things that you guys need to know. Okay. So without further ado, I will just start on the main content for matrices. First thing first, matrices. Okay. Someone told me it's not called matrices, it's called matrices. So okay, I just follow law. Okay. First thing first, very obvious. Matrix equality. When you have two things, okay, on the left and on the right, when you say that two matrices are equal, you are comparing literally top left is the same as top left, top right is the same as top right, so on and so forth. So it's really I to I, 1 to 1, 2 to 2, that kind of stuff. So right off the bat, I can see that, okay, 2 is equal to A. Okay, so right off the bat, 2 equals to A. So I will write 2. Second thing, I know, okay, B is equals to 3, right? So straight away, I will write B equals to 3, correct? Then next, I also have 1. Wait, 1 equals to C plus A. So this one need to be a bit more careful, right? Because C plus A is equals to -1. Okay, so these two matches, but I know that A is 2. So C is equals to -1 minus 2, which is -3. Just write down as per normal. Now, last one, okay, 1 equals to 1, -1 equals to -1, that is pretty straightforward. And then we have D is equals to E, and E is equals to 2, which means all these three quantities are in fact the same. So both of them are 2. Okay, straightforward stuff. Now, with regards to matrix addition and scalar multiplication, these are the main operations that you need to know lah. So when you see matrix A over here like so, okay, all you have to do is to just copy paste whatever this is. Okay. Now, then you have the minus 3b like this. So in this case, you will put a minus 3 because this 3 is just a scale. It's called a scalar multiple because you're scaling the matrix upwards, right? And then you just copy the matrix of B. So what we need to do over here is that we need to scale all of them up by a negative 3. So two ways to do it. Main thing is some of you guys will multiply in the negative 3. I wouldn't do that. I will just multiply the 3 in and leave the negative outside so that you don't mix up the signs and all that. So what I mean by that, okay, you just watch. This part over here, no change. I will just copy. This part, I will just copy as well. But the 3, I will multiply into all of the terms. So it's in a way rainbow method for expansion in algebra, right? But now it's for matrix. So the 3 I'll multiply in, it'll be 3, 9, 0, 0, minus 6, and 6. Okay, like so. Pretty straightforward. Then after that, all you have to do is to add up component-wise. It's like, 6 B's, right? This B join this B, go home. That kind of stuff. Okay, so 2 minus 3, it will be minus 1. Then 0 minus 9 is negative 9, right? Then negative 1 minus 0 is negative 1. Negative 1 minus 0 is just negative 1. Okay, 2 minus negative 6. Okay, this is a double negative. 2 minus negative 6 is the same as 2 plus 6, which is 8. And then 0 minus 6, which is minus 6. Okay. So this is pretty much all for this component. That is your simple matrix addition. Okay, so not too complicated. Now for matrix multiplication, this one be very careful. This analogy over here for matrix multiplication, I do it like a waterfall kind of technique. So what do I mean by that? I simply just take this one. Okay, waterfall is, you okay, you got fish swimming on the ocean, a river, and then all of a sudden the fish will drop down. Okay, so it's always going this direction first, then go this direction first. Okay, so it's go forward, then drop. Okay, don't confuse this with salmon fishing hours. I'm not talking about that. Just normal people, normal fish swimming downstream. So downstream action, first row, first column. Okay, whenever you take the matrix multiplication on the left, it's always rows. And then on the right, it's always columns. So in this case, it's first row, first column. The answer will be on the left. So what do? I need to pair up the numbers 2 and negative 3, negative 1 and 0. So I multiply them component-wise, then add them together. So just remember 2 minus 3 plus negative 1, 0, which you don't even have to put. It's just 0, right? Okay, so this is equal to negative 6. Okay, I'll write down for you. 2 minus 3 plus negative 1 times 0. Okay, that will give you negative 6. Okay, on the right is first row, second column, because we already cleared the first column. So first row, second column is first row, second column. Okay, this is first column, this is second column. Okay, so I will have 2 times minus 3 minus 1 times 2, which will give me minus 6 minus 2, which is minus 8. Wait. Oh, my bad. This is supposed to be 0. Okay, so this is negative 2. Lucky I spot that. Okay, next one is we finished the rows already. The row settled already. Now we move on to the bottom row, first column. Bottom row, first column will be negative 3 times 3 plus 0 times 0, which is just negative 9. Okay, so just negative 9. And last but not least, okay, over here will be bottom left, bottom row and right column. So same thing, this one is just 3 times 0 plus 0 times 2, which is just 0, very fortunately. This one not too complicated to calculate. Okay, so I hope you guys are okay. These are your basic operations, and that's pretty much all you need to know for this topic. However, I know that most of you guys struggle with matrix multiplication, but most of the time, students, right, you all will struggle in this is not the biggest struggle. The biggest struggle is in the next page, whereby we encounter word problems. Okay, so very first thing I see over here, Salim owns 3 cafes. Now, listen, all of you over here, this topic very important because why? The questions that always come out for this topic it's in particularly very important that you pay attention to the details. The details matters a lot. So first thing first, 3 cafes. And what they sell? Burgers and salads. This one, you really must take note of what's going on. Okay? And then they said the cafes operate for 7 days a week. 7 days a week. Okay? The sales on a weekend are on average half of that on a weekday. Now, this is a statement that is very peculiar. Why? Because normally nobody says this kind of nonsense, right? Like out of nowhere, the sales on weekends are on average half of that of a weekday. Right? If you see this type of information, it's out of the blue, you need to take note of that already. It's very strange. It's something that you really must take note because it's confirmed going to twist somewhere on. Okay, but never mind. Next question, they ask you to suggest a reason why the sales on the weekends are lower than that on a weekday. Maybe just to hear the ground people, anyone got any interesting answer to this not? Why do you think the sales on the weekends are cui compared to a weekday? Like, why do you think people will come and buy things on a weekday than a weekend? Let's hear some degen answers over here. I don't know whether I regret this, but let's see what you're gonna say. This one's a bit shy. I join later where to get resources. Okay, come, let me share again. Got weekday promotion. Very funny. On weekday, people more free. Interesting. They are working on weekdays, so more people. Very valid. Okay, you guys are giving pretty good answers, to be honest. Okay, yes. So weekday promotion, not really. Depends on the town. Yes, okay. Now, y'all don't PM me, y'all share in the group. Okay, so main thing I'm hearing over here, yes, I'm capturing some of the essence of the answer already. Now, weekends, y'all think as a student, y'all are in school, right? Your school, some of y'all got good news cafe or that kind of things, right? Or maybe y'all got a canteen, right? You think your canteen will operate on the weekend or not? Very unlikely, right? Why? Because you're all at home or you're all in other places. Correct? Now, similarly for working adult, our working days normally Monday to Friday. Okay, except for me lah, because I teach on Sunday lah. I'm here today lah, right? Because of y'all. So this one, okay, if you think from a normal perspective, most people work from Monday to Friday. Your parents mostly work from Monday to Friday, right? Some of your older siblings already working Monday to Friday, right? So on other days when they're not working, what happened? Go home and sleep. Why? Tired. Okay. So one of the reasons why we see weekends have lower sale is because the cafes are located at where school or work area, right, with more students or adults, working adults, visits the cafe on weekdays more than weekends. Okay, so this is the main explanation that I see from the answer key lah. Okay, this is one of the answer. I will probably accept a few more answer. But weekday promotion, also okay. Weekday promotion, I would say depends on availability. If you're not available, probably not. Okay, you can take me for example lah. I think for me it's a good thing lah because I get a bit more time in the day lah, right? Working on the weekday, so more people. Yes, this one I already said already. Weekday, yeah. Okay, but weekday more people free. This one is very vague. So you need to give a bit more specific. So Lionel, just take note of that. Okay, you need to be a bit more specific with your answer. Cannot be too vague. But anyways, only 1 mark. Don't stress. Focus on the next part. Okay. In cafe A, 120 burgers and 11 salads were sold on average on a weekday. Okay, every weekday, 12 burgers and 135 salads were sold on Cafe B, right? So Cafe C, 80 burgers and 92 salads. Okay, so you can see, all got burger, salad, burger, salad, burger, salad. Okay, and burger, salad is all over here. A, B, C is over here. So you should know how to put in the numbers already, right? 120, 11, 12, 135, 80, 92. Okay, that is pretty much what you need to do. Okay, so just fill in this table. Okay, and then the next question asks you to evaluate 6f. 6f very straightforward. W is equals to 6f equals to 6 times of the matrix. Okay, equals to 720, 66, 72, 810, 480, and 552. Okay, so this is your matrix F. Okay, now before I carry on, I mean, you guys know how to multiply by 6 lah. You guys are not that bad lah. You guys are quite okay one, right? The next thing to take note of is that what is this 6f all about? Where did the 6 come from? Right? And F is the daily sales, right? Is it on average every day? But why 6f? 6f means 6 days. But the question say they operate on 7 days, you know. Why? Why is it not 7, but why is it 6? 6, 7 not intended. Okay, but why 6, not 7? Okay, for that, we need to move on first. Okay, in all his cafe, each burger costs $12 and each plate of salad costs $8. Represent this as a 2 by 1 column. Okay, so 2 by 1 column, right? It is always row, then column. Okay, always rows and columns, right? So rows and columns, right? You will put it as 12 and 8 like so. Wrong. Yeah, correct. Okay, like this. So this is a 2 by 1 column, right? Make sure you label this as C. Okay, make sure you label this as C. Okay, can okay, if not, I'll leave this for a while. Anyone got any questions want to ask me? Okay, I'll leave this for a while first. Okay, if not, let's move on. Part D, evaluate R equals to WC. Okay, so WC is this matrix. Okay, this matrix multiplied by this matrix. Hey, guys, take note, the order matters. So if it's WC, make sure it's W first, then C. Okay, for matrices, this one very important. Now, we're going to apply the waterfall method that I taught you earlier on, right? So you go this, then down. Okay, it will be 720 times 12 plus 66 times 18. 8 times 8. Okay, following which, the next row will be this and this. So 72 times 12 plus 810 times 8. Then finally, 480 times 12, 552 times 8. Okay, so use a calculator to evaluate all this. I'll give you guys an example. So if you take a look on the left. Okay, so for example, 720 times 12 plus 66 times 8. Okay, you get 9168. Okay, rinse and repeat for the bottom for the rest of the parts. Okay, 72 times 12 plus 810 times 8. Okay, 7344. Last but not least, 480 times 12 plus 552 times 8. Okay, so the answer is 10176. That is your matrix. Okay, so that's pretty much all for this part. Then in part E, they ask you to state which of each element of R represents. Now, I would say this one really depends on the school, because I noticed that there are some schools which are a bit more strict with how you represent. Because if they say each of the element, it's possible that you are really looking at things like this number represent what, that number represent what. Okay, so for us to investigate that, we need to first look at what are the labels in your evaluation here first. So this is our cafe A, cafe B, cafe C, and this is our burger, this is our salad, and this is our cost, right? Okay, so if you think about it, when you evaluate these, right, you are taking the burger times the cost, you get the total cost of burgers, right? And then you add up the cost of salad, 66 times 8. all together you get the total sales, right? The total cost. This one also very important because specifically cost. The keyword here is cost. When you're evaluating, this is called cost. Okay. So when you calculate this, use the correct terms. If they say cost, just use cost. So when you add them up together, get the total cost, right? But you noticed this information was retained. The A was kept because it went this way. The number, you see, like A is a subject, right? It remains as a subject. So this is still A, this is B, this is C. But what happens over here is that the information is absorbed. You get the total cost. But remember, this matrix over here was the result of 6F. Okay, the number 6. Why is it 6? Because remember earlier on, we mentioned about this phrase. The sales on weekends are half on average than a weekday. So if one weekend is half of it, 2 weekends is the same as 1 weekday. So you are effectively operating on a 5 plus 1 equal to 6 weekday equivalent, but this is the amount that you generated throughout the entire week. It's not just 6 days, it's the entire week. It's just that your weekends are half as productive as your weekdays. Okay, so therefore, the reasoning for this, okay, $9,168 is the total cost of burgers and salads in Cafe A in 1 week. Not 6 days, it's 1 week. Okay, it's in a week. Very important. Okay, then 7344 is for Cafe B, and 10176 is for Cafe C. So you don't have to copy paste this entire sentence. You just need to say, okay, this is Cafe A, this is Cafe B, this is Cafe C. Good enough. This is the most possible full answer that I probably accept lah. Okay. But if your school allows you to be a bit more stringent, then the main thing I must see is total cost of burgers and salads in the respective cafes in a week. Okay, the keyword over here is in a week. Any part over here missing, you lose marks already. You will just get 0 straight away. Okay. Okay, some other answers they accept is the amounts of money collected. Because this is a great area, right? These numbers are the numbers where it was sold, right? The burgers and salads were sold. So, in a sense, the cost price is the cost price to the consumers, to the people who are buying the thing, not to the people, not to the restaurateurs lah. Okay, Saturday is considered a weekday. No, Saturday is half a weekday. If you read very carefully, sales on weekends are half of that of the weekday. It's not that Saturday is a weekday. It's just that the sales resulting of that is half of that of a normal weekday. So two weekends together is 1 weekday. Does that make sense? So that's why the number 6 is there. It's not 7, it's 6. Cause 5 weekday plus 2 weekends, which is the same as one extra weekday lah. So 5 plus 1. But end of the day, this whole calculation is for 1 week. Okay, it's still for 1 week. It's an entire week, not 6 days. I hope that answers your questions. Okay, yeah, no problem. Okay, then now the last part, this one, they like to come up with very, very funny questions, right? All the food are sold for 40% profit. Okay, so listen very carefully, the part E, right, those dollars that you see over there, okay, these are your selling, the sale, right? And they said the food are sold for 40% profit. So if you look very closely, 9168, 7344, and 10176, right? These are actually your sale. Not profit, not cost, is sale. So sale, right, means it is the cost, and then on top of the profit that you're going to earn. So it's add up together. So sale is cost plus profit. Okay? So they are saying that this is sold for 40% profit. So if profit is 40%, means your selling price must be your 100% cost on top of your profit, which is 140%. So all of these numbers, right, the base is not 100%, it's not 40%, it's 104%. So they want you to calculate the profit. Means I am trying to convert from selling to profit, which means I need to divide everything by 1.4 and then multiply by 0.4. So this is a factor that will convert one of these number into the profit. But listen very carefully, they also said they want you to write a row matrix such that TR gives the total amount, which means I am going to add everything up. If I'm going to add everything up, means I must take this multiplied by this, plus this multiplied by this, plus this multiplied by this. So all three of them, I must scale them into the profit and then add them up. That is why we need a row column. Okay, this question, right? I mean, rightfully so, you can just put it like that. It's a scalar multiple. But this does not add up the three elements together. So instead, what you need to do is to put a row matrix duplicating all these three together. Okay, and so this is the same as you add everything up and then you multiply by this factor. Okay, so in a way, you can say, first of all, 0.4 divided by 1.4 is 2 out of 7. Then you can just add all of these three up. So for example, 9168 plus 7344 plus 10176. So add all of them up first. Okay, then you divide by 7 times 2. Your answer is, oh, very strange. Okay, $7625.14. Okay, 2 DP because it's in dollars. So therefore, this is your final answer. Okay, so I hope this makes sense to all of you. Okay. Okay, so if any questions, you'll let me know. Yes, I got a question. Can write fraction in matrices? What do you mean write fraction in matrices? You mean the 0.4 over 1.4, that is literally the answer key, but yes, you can do that. Because, okay, the philosophy is that as long as it's not the final answer, right, it's fine. I hope that makes sense. Final answer must be simplified, but in writing inside the matrix, no issues one to be. Unless that is that's what you're presenting, then make sure you simplify it. Okay. Anybody else still need to access the folder or not? The document. Let me know. I can resend it again. Okay, if not, let's move on. Okay, I will cover hopefully a few more questions, okay, before I take a break. Now, question 2 will be on completing a square. So we just do a quick one. Completing a square is actually very straightforward. Okay, so what we're going to do, right, is for for this question, solve this by completing the square. Okay, so what we need to do is every time you complete the square, this is what I like to do. Okay, I will first draw out a diagram. Okay, like so. Okay, then I got x squared and I got 5x. So you need to think, x squared is a perfect square. I can put it over here perhaps. Okay, and this square is made up of x times x. This 5x over here can be split into here, here, or here, but I don't know where I want to put, right? So the thing is this. Okay, I need to consider 5x itself is not going to look like a square, because if it's a square, I will have like 7 squared or 7x whole squared, but 5x cannot be done this way, right? So what's going to happen is that I put 5x, okay, 5 will become 2.5x. Or you can put 5 over 2x. 5 over 2x. So this 2 will give me this. Okay, so x squared gives me this 2 gives me that. Okay, this minus 32, I leave it out first. It's okay. Then on this side, this is x. This one must be 5 over 2. So if that is 5 over 2, then this is also 5 over 2. Then I actually have a missing square that I don't actually have, right? And this missing square is got the sides 5 over 2 and 5 over 2. So what I'm missing over here is 5 over 2 squared. So in order for me to factorize this fully, I will need to take x squared plus 5x. Then I will add in the square that was missing, which is 5 over 2 power 2. And then I will take this away because I need to balance it out. And last but not least, not forgetting my 32 at the back. Okay, I can put equal to 0 first because this question asked me to solve this directly. So this is the general procedure for coming a square. I think most of you guys should know how to do this already lah. Also, this is just a revision. Next is this part can be factorized if you look at my square. Because this one, once I include in this portion, this becomes a square. Because I have this and this as my side lengths. So therefore, I will have x plus 5 over 2 whole thing power 2 minus 25 over 4 minus 32 equals to 0. This component over here, okay, and this component over here is a very good thing that we have done this now because x is now a term by itself. These numbers can then therefore move to the right and we will have x plus 5 over 2 power 2 equals to 32. This part move to the right lah. So what I will have now is 32 plus 25 over 4. So that will give me 38.25, I believe. Okay, and once I move everything to the right side, I can proceed to square root both sides. So x plus 5 over 2 equals to plus minus square root 38.25. Then x is equals to negative 5 over 2 because I move this whole thing to the right. Okay, plus minus square root 38.25. Okay, so using a calculator, you simplify, you get 8.68 or 3.682 dp because the question requires 2 dp. Okay, so that is the general procedure. Just double check you guys are okay. Okay, have a look first. Okay, I'll leave this up for 1 minute. Okay, no questions? Okay, if not, I will move on first. Okay, let's move on to the next part. In fact, I will give you guys a break first lah, because I think you guys need to process a little bit. I would say there are some issues with the matrix question. Maybe I will give you guys a quick 5 minutes break to go and sort out what is required. Okay, so you're going to think through first, see what you want to ask me. In the next 5 minutes, I go toilet first, I come back, then I will look at the questions. Okay? I think complete the square is okay lah, huh? Yes, okay, I got questions. What's the general formula for completing a square? Okay, general formula for completing a square is I mean I wouldn't go memorize it, but I will just share with you. So first thing first is that general formula x squared plus bx. Okay, is that ax plus b. Okay, this one the general formula is you keep the first two terms, which is x squared plus ax. Then you insert, okay, a over 2 whole thing squared minus a over 2 whole thing squared plus b. Okay, so that this component, okay, is just a plus x plus a over 2 squared minus, this part just copy and simplify lah. So there's nothing much you need to do about this. Okay, like so. Of course, if there is a minus sign over here, you should put a minus sign here lah. Okay, and as well as the insides of all of these things. So minus sign here, minus sign here. But take note that when you square a negative number, there is no impact on the final value. It's just that this part will have to change this. Okay, so I hope Sarah, I hope I answered your question already. Oh, one more thing to add on. For this formula, right? Okay, for this formula, if let's say, for example, I got 2x squared minus 5x plus 6, okay, ensure that you factorize out this number. Okay, you always want to ensure that you start off with this number being a coefficient of 1. Very important. Okay, this is not very common in E-math, it's more for A-math. Because all the E-math paper I've seen so far, they don't really have this kind of complicated examples lah. But it is possible that they can test you on that. Also, if you see like negative or you see 2, that kind of things, please ensure that you factorize it out. Okay? Before you use the formula. Oh? Any questions about matrices and the quadratic, the complete square? I still have 5 more questions to go through, but the next few should not be too long. Maybe only the last one will be the longest. So hopefully for the best. Yes, I got one more question. What are some common mistakes for matrices? Common mistake for matrices is mainly your calculation. Calculation is the main issues. Other thing that you will encounter issue is in your writing. Okay, like as I told you before, right? State what each of the elements in R represent. A lot of students will forget to write these kind of things. Will forget to write these kind of things. These details matter a lot. Okay, sometimes when the question don't need you to write, you go and write it in. Okay, so those kind of situations you need to be very wary of. Part F, I would say not common mistake, but it's more of people don't know what to do, right? So you need to go back to whatever concept they've done before and then just follow from there. What other mistakes? Yeah, really just calculation error. But if you ask me, I would say more students are afraid of doing the questions rather than making careless mistakes. That is what I think lah, but I may be wrong. Okay? This is just based on my experience. I mean, if you look at my E-math class this year, a lot of them just don't know how to start. But after you just push them a bit, they get it already. So I would say that is my general observation. I hope that helps. So careless mistake and not answering the question accordingly. And also, yes, not reading the correct or appropriate information. Like see this one. Sales on weekends are average half of that on weekends. So people will not understand why times 6F, right? They'll be like, hey, sure, I thought it's 7F. Why 6F? Right? They cannot answer these kind of questions. And I thought it was a typo. Until I saw the information, I was like, oh shit. Here we go again. Okay? Yes, thank you very much. Okay, next, let's move on to graphs. Okay, so for graphs, this one, in a way, you kind of have to memorize, but there's a few ways to make your life a little bit easier. So Personally, I would say you don't really have to memorize if you understand, but there are some things that you must already know. So, for example, a quadratic, you should already know if it's a positive ax squared, it should be a happy face and should be sad face when it is a negative. Okay? And so, happy face means you have low cortisol, therefore a minimum point. Lol. Okay, yes, I got another question. How to get PDF? Come, let me send you again. Okay, come. Okay, so this one you need to minimally know. So let's use the concept of quadratic to help us with cubic. Now, quadratic, the important thing is that no matter what, right, when you square a number, it's always positive. However, for cubic, it's a different scenario. Okay, because first of all, this part will still be a quadratic, but the left part will go down instead. And that is because x cubed, when x is more than 0, x cubed is positive. When you cube a positive number, it is positive. That's why it's going up. But when you cube a negative number, you will end up having it being negative. That's why it was downwards when it is in the negative x region. Okay? And this looks like a chair. A person can sit down on it, right? So it looks like a chair. So C for chair. It's a very nice, sexy looking chair. Okay? And so, for a cubic with negative ax cubed, right? It is the reverse direction. Like so. Okay, so it's just like that, then like that. Okay, this part not very good. Let me just draw again. Make sure it's smooth. It's smooth. Uh. Okay, so I hope this helps. Okay, next. Linear graphs. Okay, linear graph not gradient is non-zero means to say that you are going up or going down. So of course, when the gradient is positive, you are going up. For those who take A math, you should know gradient going up means positive, means dy dx is more than 0. And likewise going down, like so. Okay, so pretty straightforward stuff. Okay, next. Leave this for a while. Okay, next. For linear horizontal graph, okay, same thing. If it's more than 0, means your graph is above the x-axis. Power 0. This one, the difference is power 0. So for example, y equals to 3, y equals to negative 3. So these are horizontal lines, right? Like so. Okay. Then next two is the reciprocal graphs. Now, I understand that not all of you got learned how to draw inverse proportion graphs before. Back in my days, is have and my days is 10 years ago, more or less. Oh, sound like an angst. Okay. So reciprocal graphs, what you need to do is reciprocal, when the graph is 1 over x. Okay, so of course the same concept goes. When x is more than 0, 1 over x got to be positive because you are dividing a positive number by a positive number. And likewise, when x is less than 0, 1 over x is also negative because you are dividing a positive number by a negative number, like so. So that's why the graph is downwards. Okay, now, here's the thing. For this type of graph, okay, instead of going this way, it will now be this way. And do take note that it must be a smooth graph. I don't want to see people draw like that. Cannot. This part is wrong. Okay. And most of all, this line, this thing cannot touch the axis. This thing cannot touch the axis, and it cannot go backwards. Okay. So if you know that it's going backwards, maybe you have to erase a little bit. Okay. Make sure that it's approaching the x-axis and the y-axis respectively. So similarly, this one also the same. Okay. So this is the graph. Okay, when x is positive, y is positive. When x is negative, y is negative. Okay, and same thing for this one. 1 over x, negative. When x is positive, the whole thing is controlled by a negative sign over here. So 1 over 1 over x negative is less than 0. So in that case, x is positive, y is negative. You draw down here. Okay, let me draw again. Okay, and then this two is opposite. Okay, pretty much that's about it. Can? So that is your reciprocal graphs. Okay, next. Reciprocal power -2, same concept as a quadratic, because this thing is x squared, it is always positive. So if it's 1 over x squared, both of your graphs is facing upwards. And similarly, negative means it's facing downwards. Okay, so I hope this helps. Huh? Okay, any questions so far for the graphs? Okay, I hope you guys are doing okay. Huh? Okay, next question. Okay, this one is on exponential graphs. Did I not edit this already? This is supposed to be edited. Okay, sorry. Can I just check? Okay, never mind. I will just on the spot. I don't know whether your copy is different from mine, but can you help me change this to k more than 0 and k less than 0? Okay, and then this one, right, just cancel out. Okay, I will just be drawing two graphs. You all don't need to know so many because A math is you will need to know more for A math, but not for E math. Okay, so for this type of graphs, y equals to k a power x, the normal graph that you need to know how to draw is referred from your left hand, your right hand. Okay, because on the right hand, if you look at palm, okay, I will do some magic show over here. If you look at your palm, you can notice that there is a graph that is going up like this. Okay, this is mirror image. So look at your own palm, your right hand. Okay, it's going up. So when you're facing yourself, right, when you're actually drawing it out, okay, it should be like this. Correct? So this is your exponential graph. When when k is more than 0, it will be like that. When k is less than 0, you look at your left hand instead. Your left hand, So if you look at your left hand, okay, it will look like this instead. So it's going downwards like this. Okay? So why is it like that? Because left hand is wait. Hey, sorry, my bad. I draw wrongly. Sorry. Ignore what I just said. Okay, k less than 0 means, right, for example, negative a power of x. Okay, sorry, let's unwind that a little bit. Okay, negative a to the power of x, right? This one, you are looking at drawing the graph in the bottom. Because why? This is negative y. Negative y means your y-axis flip the values. So for example, when y is 3, you change it to y equals to negative 3. So whatever value this is, right, it will go downwards like that. Okay, so whatever value this is, it will go downwards like that. So you trace this out, you will get this graph. Okay, so this is your k more than 0 and k less than 0. These are your two graphs. So for example, this is 3 to the power of x, and this is negative 3 to the power of x. I hope this makes sense to you guys. Okay? So for EMAth, you just need to look at your right hand. Right hand is the only one that will give you the answer. Then for the negative version, you just flip it downwards. Okay? I hope that helps. Okay, so once okay, let's move on to the next question. Okay, this quickly we determine which graph shown above could be the graph of y equals to 2x. Okay, so this first and foremost is an exponential graph. I don't know whether I can do a poll or not over here. But a bit waste time. Okay, never mind. Can I see in the chat what is your answer for part A? Is it figure 1, 2, 3, 4, or 5, 6 for part A? Maybe just type in the chat. I will just take a quick look. Okay. Okay, I got some answers. The rest don't know. Okay, 5, 1. Okay. Should play Kahoot next time. 5. Okay. Yes, answer is 5. Okay. This is an exponential graph. Exponential mean being it goes more and more and more. It's exponential growth. Right? So it only goes up and up and up. So answer is 5. This is figure 5. Okay. So to clarify Isaac's doubt, you look at number 1, right? This over here, when you see a graph like this is called a reciprocal graph. Okay, in particular, because x is positive when y is positive, right? This is a 1 over x form, right? So this is not a. This is not y equals to 2 power x. Okay, this is a totally different graph. Okay. Now for part B, we have y equal to 3x squared. Now to help you guys a little bit, okay, x squared once again means to say no matter what value of x, when you square it, it's always positive. So y is always positive. If you look at my graph, the figure 1 got this part, figure 2 got this part, figure 3 got this part, figure 6 got this part. So all of this part can be negative. But if you look at my 3x squared, this is always positive and there is no negative sign over there. So the answer can only be 4 or 5. But obviously this is not 5, right? Because 5 is an exponential graph. So the answer for part B is figure 4. Okay, figure 5 and then figure 4. Now last but not least, this is a linear graph. So very obviously it cannot be 1, 4, 5, 6. It can only be 2 or 3. Now, this linear graph is not a direct form. It's not the form that you recognize. So to determine whether it's this or that, and by the way, both of them differ by one thing. It is the gradient. One goes up, one goes down. So we need to take a look at the gradient by making this into the y equals to mx plus c4. Okay, so y equals to mx plus c means y equals to negative x plus 1. The gradient is clearly negative. For AMF and EMF students, please take note, you need to know this very well. Okay, so if the gradient is negative, we are obviously looking at figure 3. So the answer for this is fig 3. Okay, I hope it's clear to you. Anybody got any questions, you can let me know. Okay. All right. Next, let's move on to the next question, or rather the next phase of the topic. Okay, this is on distance time graph. Distance time graph. Okay, okay, so this one I need to know two things. Okay, distance time and speed time. The main thing we are really focusing on is on two things: gradient and area under graph. Okay, so you need to understand the interpretation of this. Okay, now gradient, right, is measured as the y-axis divided by x-axis, right? And what do you get? The y-axis is distance, the x-axis is time. So in a distance time graph, the gradient represents the speed. So all of these over here, these are all speed. So if you look very closely, this is 27. This is a flat line, right? Flat line means the gradient is flat, is 0. There is no speed. Here also same. So in these two scenarios, when it's going up, this speed is positive, positive. Okay? For speed time graph, same concept. The gradient is speed over time. And this quantity is none other than acceleration. For those taking AMF, you will be hearing this very soon for your next topic in AMF for kinematics. Okay, so acceleration is the gradient. Okay, next, the area under a speed time graph can often be looked at as, for example, this is half times the y-axis times the x-axis. So it's speed times time. And if you think very carefully, speed times time is actually distance. So what does that tell me? The total area under the graph gives me the accumulated distance over time. Okay, so this over here should be distance. Okay, distance. Okay, so now we'll look at the three different scenarios that you must know for speed time graph. The speed time graph. Okay, when it comes to the area, because a lot of students don't know how to draw these things and they don't really understand this. So to help you guys to understand a bit better, we will look at the following scenarios. If the speed increases, the distance covered is okay. If you drive a car, just imagine, okay, those who don't drive, okay, none of you drive car. Some of you see in parents' car. Some of you go to time zone and play the arcade. One gun midnight 6 or initial D, I don't know. Okay? You just imagine you're in the car. If you step on the accelerator, you are speeding up, right? And if you're speeding up, every second, will you be covering the same distance per second or more distance per second? So if you're speeding up, confirm you cover more, right? You will cover more distance every second. So your distance when you draw a distance time graph, it should increase. It should be going up. So it is more than proportional. Okay, very important. If your speed is constant, like yesterday I was driving, right? Because I have not drove a car for almost a year already. Because no car Then suddenly yesterday I was asked to drive. So of course, me being me, I a little bit scared a bit apprehensive Because different car never drive before. Right? So if the car is if you are scared like me, okay, I will drive at a constant speed. So like I will just follow behind a car 60 kilometers per hour, right? So you will feel that there's no change in my distance, right? Every second I cover to need maybe what? 10 meters, 20 meters, right? Next second, 20 meters. So what does it mean? Every second you 20, 20, 20, 20, 20, right? You are going to go up flat. It's a straight line. Okay. So if this is your distance time graph, your speed, your distance should be a straight line. Or you are covering the same unit per second. So therefore, the distance covered is proportional. Okay, no prices for guessing what happens if you slow down. If you slow down, of course, you'll be covering less. But that doesn't mean you are decreasing in distance. You are just slowing down. You are still going forward. Okay, for EMF, don't overcomplicate. You are going forward. You never go stun. You never U-turn. You go forward, but you are slowing down. Slow, 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 slow. Right? So if your speed decreases, your distance will start to naturally flat out. Okay, less than proportional. Okay, very important. Okay. Okay, so I hope this is clear to everybody. Okay, now with that, I hope it's okay for you guys. So I'll be moving on to the example. Okay, this is the question from a school, like every other question. So what we have over here is a speed time graph. Okay, and we have a car and a lorry. This time I got car and lorry, So they travel in the same direction. Both vehicles begin journey at the same starting point. The lorry accelerated for 30 seconds, then traveled at a constant speed of 20 meters per second. Oh, right behind me got a car speeding up. Very, very, very cool one. Okay, lorry accelerated, go up. Okay, for 30 seconds. Wait, is that a typo in this question? Hold on. Okay, this question very strange. Oh no, this is a totally different question already. Okay, sorry. I need you all to make an edit to this diagram. Sorry, may have copied the wrong diagram because maybe I changed it out or something. So I'll just do a quick change. Okay. What I need y'all to do is y'all just help me to just draw this out. Okay. Let me see. Okay. So I just draw out for y'all. Okay. This is 20. Okay. Lorry accelerated for 30 seconds, which means this is the lorry going down like that. Okay. Then after that, it will go straight this way. Then you put lorry. Okay. So this is 30 seconds. Okay. Then next is the car. Car, I will go up this direction. Car. Okay, so the thing about car is that where's the car? Car accelerates at a uniform rest. So this should be correct now. Okay, I hope this helps. Apologies for the issues. Okay, I'll give you guys around a minute to copy this down. Okay, so sorry about this. Okay, in the meantime, I think this question is very straightforward. Based on the information given, is pretty much tallies with what is given in the graph lah. Okay, and this is really not too complicated. So okay, one more thing to add in. This is speed and this is time. Okay, if not, we can proceed already. Okay, now find the speed of the lorry at 12 seconds. Okay, so 12 seconds, you really must look at somewhere around here. 12 seconds is somewhere here. Okay, I use a different color pen. Okay, and they said lorry. So over here, lorry, the thing is that we want to find the speed. So we need to read this off over here. But how do we read this off? We don't know, right? So there are a couple of ways you can think about doing this. First way is you can use the concept of similar triangles. Because this triangle and this triangle are similar, right? This angle is common angle, and these two are right angle. So this is a AA similar triangle. Okay, so what we know is that the speed is S, the time over here is 12 seconds, which means the ratio S over 12 should be equal to 20 over 30. Therefore, S is equal to 12 times 20 over 30, which will give me 8 meters per second. Okay, so this is your answer for part A. Okay? Okay, any questions? This is pretty straightforward. Now, some of you guys may be thinking, sure, can I calculate acceleration first? And then I use that to go and find my speed? Can also. Okay, you can do that first. No problem. But I would say similar triangles is easier. It's very straightforward. And for this type of question, most of the time, similar triangle is enough already. Okay? Okay. If not, then the next thing to do is to draw the distance time graph for the lorry. Now, initially, the lorry speed up, right? Which means the lorry must cover up this distance. It must first go up first. Once you cover that distance already, the next thing to do is that the lorry will stay flat, which means the distance covered is going to be a uniform kind of thing. So every second, same distance. You stack 20, 20, 20. So 20, 40, 60, 80, 100. Okay, you are stacking up. So in this part of the diagram, you just draw a straight line going up. Okay, like this. Okay. Now, the other thing that you must take note of is that for this type of question, they always want you to go and draw out the distance in each juncture. So this one is where you need to do a bit of calculation. Okay, but thankfully this question is not that complicated So the first part is this triangle over here. The area of this triangle can be found by half times 30 times 20, right? Because it's 30 and 20. So this will give me 300. So in the first 30 seconds, the lorry traveled 300 meters. In the next, don't know how long this is. Okay, they never say anything. Again, it is until 50 meters. Okay. Did they say 50 meters? I don't know. So maybe it just indicate 50 meters. Okay, so at 50 meters, sorry, not 50 meters, 50 seconds. Okay. From here to here, this gap is 20. This gap is 20. So this is a rectangle. And a rectangle means the area of this is 400. So if you are already at 300, this portion you will need to add another 400. So altogether is 700 meters. Okay, so you need to label your graph very clearly and you need to have the correct shape for you to get the full 2 marks. Sometimes this type of question will be 3 marks. So you need to be very careful about that also. Yep. Can I? Okay. If not, I'll leave this for a minute. See if you guys have any questions you want to ask. Okay. Anyone need more time to draw the graph? I apologize for the graph. I don't know why the graph copy wrong. Could be I open 2 tabs, then I one folder, then oh wrong, die. Okay, then I think nothing else. I will just move on. Okay, the last part is that they want you to find the time taken for the car to meet the lorry. The word meet means you need to ask yourself, if I were to come and find somebody, let's say for example, let's say me and my father at home, right? I go out to Tampines Century Square, right? 500 meters in one particular route. If my father want to meet me from home, right, he must travel how long or how far to meet me. If he take the same route, of course, want to meet me, he must take the same distance as how I travel. It's not based by time. He can stop, sit down, lepak, drink, read newspaper, drink kopi out of nowhere, then I don't know lah, I don't know what nonsense to do lah. But if he go by the same route, okay, the distance must be the same. So the key thing over here is the distance must be the same. So they want you to find out what's the total distance for them to meet. Okay, and so I will copy this whole thing into the next page. Okay, so that we can process this together. Okay, so it's very important. Let's have a look over here. Okay, so first thing first, I'm going to erase all of this. Is this enough? Okay, can. I think it's good enough. Okay, next, the car, I don't know how long it will take to travel, but it's going to be around maybe T seconds. Okay, let this be T. Because I don't know the distance traveled by the car. Okay, I need to find the time taken for the car to meet the lorry, so I don't know when that will happen, right? And the other thing is that I also don't know what is the speed. I don't know what is the speed at that point of time, right? So, the other thing they mentioned is that let's see, the car accelerates at a uniform rate of 0.5 meters per second. Okay, second square, so the acceleration of car. Okay, so this is important, right? Because we haven't used this information yet, right? And the lorry also travels at a 20 meters per second speed after a certain time. Okay, so what we can do first, right, is that we can look at the car portion and the lorry portion. Okay, the car portion and the lorry portion. So for the car portion, 20. Okay, we look at car first. Okay, car first. Okay, for car, we need to take the formula half times the speed times the time. Okay, obviously I don't know what's the speed. So I need to find a way to calculate the speed, right? And for us to do that, we need to make use of this. Okay. Obviously is the car is at a uniform acceleration, right? Which is 0.5 meters per second. So think about it. How do I get the speed at time t? Okay. At time t, the speed, okay, acceleration is equal to s over t, right? So the speed is the same as the acceleration times time, which is 0.5 t. So this is the speed of the car at time t. If you draw a dotted line like this, okay, if you draw a dotted line like this is 0.5 t. That is my speed. So this will become half times 0.5 t times t, which is 1/4 t squared. Okay, so this is the distance by the car after t seconds. Okay, so you just need to base on the formula first, and you know that the speed is unknown. You must make use of relevant information to find the speed. Okay, next, to find the lorry. Okay, lorry, lorry, I have two components. This is the first one. First component, this is 30, this is 20, so half times 20 times 30 is 300. The remaining time is the gap between these two. So the gap over here is the rectangle, 20 times t minus 30, which I don't know what this is. So the total distance traveled by the car after t seconds is 300 plus 20t minus 30. Okay, and for them to have the same, to meet at the same point, they must have the same distance. So now finally we will equate them together. 1/4 t squared equals to 300 plus 20t minus 600, which reduces to 20t minus 300. Okay, so therefore t squared equals to 80t minus 1200, t squared minus 80t plus 1200 equals to 0. So this is a quadratic equation, ladies and gentlemen. Okay, your job is to take a calculator, go and calculate the answer. Okay, so if you go to my calculator, yes, you can use calculator to go and check your answer. So 1 minus 80 and 1200. Okay, if you get this out, your answer will be t equals to 60 or t equals to 20. So let's have a look. T is 60, right? It will be the same as you factorize t minus 60 and t minus 20. Okay, equal to 0, and then you get this to as the answer. But the thing is, can t be 20 or not? Okay, can the time taken be 20? What? Who's that? Okay, t cannot be 20, because if you look at this again, 20 minus 30 is negative 10. This is undefined. So this is not, it's not possible for this to be 20, okay? So we must reject. Okay, so t must be 60. So the time taken is 60 seconds. Okay? Quite a lot of work for 4 marks, but actually it's a very straightforward process. Okay, so I'll leave this for a while. Go and take this down. Okay, I will say first, I am confirmed going to overrun this by maybe 10 minutes or so. So those who need to go off, you all can go off first. Okay, I give you guys another 30 seconds to go and look through first. Okay? Right. Okay, I move on. Okay, next one. Proportions. Okay, proportions I will go through a lot faster because it's not supposed to take very long. So for proportions, right? You just need to know when it's directly proportional, you write this formula. So y is equals to a multiple of x. Okay? If it's xn and ym, you write it like that instead. Now, if it's inversely proportional, you put k over x. In the same way, in a similar way as y is going up, but x is at the bottom. Right? So it's inverse because like that. Okay, one up, one down, one up, one down, like that. Okay? Then down here, when x increases, y is increases. So that's the meaning of direct. When both go up, when one up, the other one must go up. When one down, the other one must go down. So the graph for this type of question is really just a straight line. It's a straight line that passes through the origin. Okay? Then on the other hand, if it's an inverse relation, this is like a reciprocal graph. You draw this instead. Okay, but only the positive portion. Okay, so only this part. Okay, now percentage change, this one I think you guys should know by now, but percentage change is your final value minus the original value. So when you take, let's say for example, now you have $1,000 in savings, right? 1 year ago you have 5,000 in your savings. So how much do you save over the year, over the last year? If you take your current amount, the final amount, you subtract the original amount. So 1,000, you take away, sorry, 10,000 take away 5,000, right? This is how much you save, lor. So that is your change, right? But you must compare to the original value. So it is like 10,000 minus 5,000 over 5,000 equals, then you multiply by 100%. This is actually, if I'm not wrong, is 100%. So what this means is that your change is actually a 2 times, is 100% increase. Okay, that is how much, basically you double. Okay, now we look at question 5 and 6. P is inversely proportional to the square of Q. Inversely proportional to the square of Q, right, means you will first thing write P is equals to K over Q squared, because they say square of Q. Now, given that Q increases by 10%, this is what I will write. P initial is equals to K over Q initial squared. Because this is before any changes that happen, right? Your job is kind of to find the constant, the K. Okay, so K equals to P initial Q initial squared. Okay, if you were to solve a normal inverse proportion question, you always find K, right? So this is the same way as I'm doing. Okay, then next is, the thing is that Q increases by 10%, right? So you know that the new value of Q must be 1.1 times of the initial value of Q. Am I right? So this is the important fact. This gives me this. Okay, so this is a very, 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 very important fact. With that information, you can then proceed to find the final value of Q of P, which is K, which actually we know what K is, right? K is this over Q final squared, because this is the final value. This is our K. This is our K. So you know that Q final is 1.1 times of Q initial. We are going to replace that with the following. So we will write P initial Q initial squared over 1.1 Q final. Q initial whole thing squared. Now this square, right, by the law of indices, we can split it up into here and here. So what we now have is that P initial Q initial, okay, over 1.1 squared Q initial squared, which you then can cancel these two. You will get P initial over 1.1 squared. So this is the new value of P final. Okay, the final value of P, this is what we have. Okay, Now, once you have this ready, right, the next thing to do, okay, is of course to apply the concept of percentage decrease. Okay, for percentage decrease, what I will do is I will just simply take P final minus P initial over P initial. And then I'll multiply by 100%. Okay, let me write it a bit clearer for you guys. Okay, so therefore, P final, I already know what's P final. P final is this value. Okay, so it's P initial minus over 1/1 squared minus P initial over P initial. Now, if you think of it this way, this is like algebra, right? You have P initial, P initial, P initial, right? I don't need all this. So what can I do? Okay, after you times 100%, all these things can cancel. So what you'll be left with is 1 over 1/1 squared minus 1 over 1 times 100%. This whole thing you can just simply key into the calculator. Okay, let's do it. So 1 over 1/1 squared minus 1, okay, times 100%. This will give me 17.4%. Okay, so this is negative. So therefore, the percentage decrease is 17.4%. That is my percentage decrease. Okay. This one is a bit confusing, I get, but you need to know how to do this because it's very common. It's actually quite common in the G3 scene. Oh, so just need to take note of that. Okay. Okay, the next question will be a bit easier. So I will just run through that very quickly. For part 5, just get the idea will do lah. Okay. For question 6, okay, let's do this quickly, because I still have one more question at the back. Okay. Once again, those who need to go off here can go off first. Okay, when a ball is dropped, the distance d it falls directly proportional to the square of time. So what I need to write is d is equals to kt squared because the time is squared, right? My job, as is in the previous question, is to find the value of k, right? So to find the value of k, I first need to take note that the ball falls this distance in the first 8 seconds. So obviously, d is 320, t is 8. So 320 equals to k 8 squared. Then you will find that k is equals to 5. Since k is 5, the formula will now become d equals to 5t squared. Therefore, for it to fall 80 meters, you let d be 80. So 80 equals to 5t squared. And then you work your way backwards. T is equals to 40. Wrong. Equals to 16. So t equals to 4. Obviously, you reject the negative. Okay, because time cannot be negative, right? So therefore, it takes 4 seconds. Okay, it takes 4 seconds. Okay. So I hope you can see. I'll leave this for another minute. Okay, go and have a look, see whether everything is okay. If okay, then I will proceed with trigonometry, the very last part. Okay. Okay, any questions so far? No, ah? Okay, if not, then let's move on to the last question. Okay, there's only one more question left lah. Okay, so this one, I hope I just take 10 minutes to go through. Okay, 15 max ah. Okay, trigonometry, tangent theta, this one you should know ah. The right angle triangle dictates that if this is your reference angle, this is opposite, adjacent, and hypotenuse. The opposite side is always opposite the angle. Adjacent is always beside the angle. But hypotenuse is special because it is always opposite the right angle. So tangent, cosine, sine, you use this acronym called Tuakaso. Okay, I believe all of you know this already. So those who don't know, maybe you let me know. Okay, Tuakaso means tangent is opposite over adjacent, cosine is adjacent over hypotenuse, and sine is opposite over hypotenuse. Okay, then if the angle is obtuse, there are three formulas that you need to know how to use. Okay, so I'll write the first one. If you have sine 180 minus theta, you don't know what to do, you can always convert it into an acute angle by taking its complementary angle. So it's sine of theta. Now, you can do the same thing for cosine, but the only difference is that for cosine, you must put a minus sign. So minus cosine theta. Then tangent 180 minus theta is equals to negative tangent theta. That's about it. Okay, so the only thing that doesn't change is that sine doesn't change. Okay, so these three identities allows me to convert obtuse angles into acute angles. Okay, from become kawaii angle lah, cute angle lah. Alright. Okay, but the only thing you must take note is that the cosine and the tangent is both negative. The sine will remain positive. Okay, so for this one, the next part, area of triangle, sine rule and cosine rule, these three okay, are all in the formula. Okay, you just need to know how to apply. So this one I won't waste time now. I will go through later on. Okay, cosine rule can be rewritten by making this the subject. So if I move a squared, b squared minus c squared, I swap these two out, and then I divide 2ab, this will give me cosine c. Okay, this formula don't need to memorize. You can just on the spot go and derive it on your own. Okay, don't go and memorize this. Okay, your brain space enough already. Don't hurt yourself. Okay, now once that is done, let's move on to the very last question. Okay, I'm not done yet. Okay, angle of elevation depression. Okay, this one actually is just alternate angles. Nothing too complicated. So if they say that the angle of depression of elevation from A from B, then B is the reference. Okay, so what I write over here, A is your end point, B is your start point. Okay, it really depends on the keyword from. Okay, and likewise, bearings. Bearings, you must take note of two things. Bearings is always measured from the north direction. So north, go clockwise. Okay, if the bearings is 60 degrees, right, you write 060. Okay, always ensure there's 3 digits. Even if it's 007, James Bond, okay, you must make sure that you write it in this manner. Okay, so if they say bearings of B from A is your start point, B is your end point. Okay, so the word from tells you the reference. Okay, so we will do one last question, fast game, then we call it a day already. Okay, so just hang there. Okay, question 7. Wow, so many parts. Okay, I'll try my best. Okay, for question 7, part A, let's have a look at the information first. Okay, so we have 33, 204 is the length over here, 142 is the angle over here, 50 is the angle over here, and C is 300 degrees. Okay, so now find the bearings of C from A means we look at A, we draw a north from A, and then we look at C. So from this north pole to C, we are interested in this angle. Okay, so this angle, how to find? Okay, you just need to take note. whenever there's a bearings questions, you can always take note that all the north pole are parallel to each other. So for example, you notice that I actually have this formation, right? If I want to find this angle, I need to know this angle. But this angle is actually just angles at a point. So therefore, what am I trying to say? This angle over here is just 360 minus 300 equals to 60 degrees. So this part is 60. This is angles at a point. And once you know this angle already, right, you can then find the bearings. Okay, so bearings of C from A is 180 minus 60 equals to 120. This one, the reasoning is interior angles. Okay, but these two are interior angles. They're facing each other. Right, so it's inwards looking. Okay, that is for part A. Okay, once done, next question is to find angles BAC. Okay, this is very straightforward because if you notice, B is due east of A, which means if B is due east of A, this is a right angle. So the angle BAC is simply just 120 minus 90 equals to 30. So this angle is 30 over there. So angle BAC is 30. That's it. Done. Okay, so far the questions are quite straightforward. You just need to open your eyes a little bit. Okay, bearings question, you tend to be able to use your old properties like angles at the point, angles on a straight line, vertically opposite angle, all this nonsense. Okay, parallel line properties especially. Okay. Next, show that AC is 221.19. Okay, AC is this length over there. This is AC, yeah. Okay, this particular length. So obviously you need to look at the information that is surrounding this. Okay, we have 50 and we have 24204. We have this angle and this angle. I'm not sure what else we can do with this. But if you notice, this triangle has one length, we are finding one length, and we have two angles. Now, if you have two angles in a triangle, obviously we know the last one, right? So we know how to find this. Whereas on the other hand, AC, if you look at the perspective of this triangle, I don't really have this angle. I don't have this angle. I don't have this angle as well. So I got no angles at all. I don't know what I can do with this, right? So the best bet is to take the opportunity of this triangle, right? Okay. If you draw, okay, not very nice graph. Let's draw again. Okay. If you notice, this is A, B, and C. This is 50. This is the one we are finding. We know that this is 30 and this is 142. So to find this, we have a lot of angles and we don't have all the three sides. So cosine rule and sine rule is the main thing that we use to tackle this kind of questions. This one in particular, okay, if you notice, if I don't have all three sides, I cannot use cosine rule because cosine rule, you need three sides plus one angle. If you only have two sides, you cannot use cosine rule. So the best bet is to use sine rule. So sine rule, this unknown, you need to look for the opposite pair. So for example, this length over here is opposite the angle 142. So AC over sine 142 is equals to something over something. So obviously I can take 50 over the opposite length, which I don't know what this is, but I can calculate because I know the other two angles. So this will be the sine of 180 minus 30 minus 142. Okay? And so AC is equal to 50 sine 142 over sine 8, which will give me 221.1855 or 221.19 meters proved. So you need to know when to use cosine rule, when to use sine rule. That's about it. Okay, I'm left with three more parts. Yes, I can annotate the annotated copy here. Once I'm done. I think it will take quite a while. I mean, okay, I will forward the annotated copy. You just take from the Google Drive, can? I think that will be better for you. Okay, so you can come back and get it again. Okay, so this for a while first. For those who need to take down or what, you can go and take down. And this will be uploaded, don't worry. YouTube will have, everything will have. Okay, okay, can Next question. Find the area of triangle ABC. Triangle ABC, okay, is this over here. So it's the same triangle. Now that I know my lengths, okay, and I know that this is 221.19. Okay, 221.19, right? So in this instance, to find the area, this is not a right angle triangle. So for triangles, right, when you want to find the area, you either use your half times base times height, or if you cannot, you must upgrade. It's like Panadol don't work, you must use something stronger, right? You must use ibuprofen. So in this case, we need to use a stronger medicine, half AB sine C. And how to use this is that the angle C, which must be in between the two lengths. So in this question, once again, as I said before, we only know this length and this length. We don't know this one. So the angle we are looking at is 30 degrees. This is the one that's sandwiched between the two lengths. So this is 30, this is 50, this is 221.19. So therefore, half times 221.19 times 50 times sine 30 will give me the answer 2764.875 equals to 2760 meter cube. Okay, nearest 3SF. Okay, so this is pretty straightforward. So many parts. Very irritating. Okay, those who need to go off, you can go off first. This will be recorded, so don't worry too much. Okay, this is being recorded. Okay, next, we want to find the angle DAC. Okay, so at this point of time, I think cannot already lah. Let's move this to the next page. Okay, copy, paste, the handwriting. Okay, so angle DAC, okay, is here, which is actually this component over there. Okay, DAC is, let's see, how to find DAC. Okay, DAC is this angle, not this whole thing, sorry. So the question is how? How can we go and find this angle? Okay, so this question, the trick is to draw a dotted line. Okay, normally, right, if you draw dotted line, it will help you a lot. So how does this dotted line help? Okay, we shall see. Let me erase this first. Okay, so if you draw a dotted line, you realize that, okay, this is parallel to this. So I know I can alternate angle over here. This is 33. Same thing, I can alternate angle over here. This is 60. So angle DAC is equal to 33 plus 60 equals to 93 degrees. This is by alternate angles. Okay, so alternate angles is given like so. Then we will use to find this distance. Okay, sorry, let me move this up. Whew. Okay. Then they want you to find the distance DC. DC is over here. So what does knowing this angle help us to do? Okay, if this is 93, right? Okay, we look specifically over here. 93, we need to know this length. We know this, we also know this. So ladies and gentlemen, we have three lengths, 1, 2, 3, and an angle. We can use cosine rule. Okay, so the strategy over here is cosine rule. Cosine rule, how we use? Same thing. The angle that is sandwiched is 93. We will use this opposite. So opposite is DC squared equals to 204 squared. Okay. Plus 221.19 squared minus 2 times of 204, 221.19. Okay. Cosine 93. Okay, simplify this part and then take the square root. You will get DC equals to 308.6488 equals to 309 meters. Okay, so that's very fast game. Eh? Hold on. Answer key got typo. Okay, you all can go and take down first. Let me zoom out for you guys first. Let me verify something because took the answer key from the exam paper. Okay, yes. So there is a typo in the answer key. This is the school answer key typo, not my typo. Okay, I didn't realize it, but eh? Wait, maybe it's a typo. Hold on first. Walao. Okay, no, this is correct. The answer key got typo, but this the final answer is correct. Okay, yeah. So next question, final one, really last one, okay. A tree 50 meters stand vertically at A. So at A, we are looking at this thing, someone standing on top. So let's draw A first. A and a fella standing on top. This is 50 meters. It's a tree. Okay, find the angle of elevation from D. So this is AD. We know that AD is 204. This is the angle of elevation. Okay, from D, so it's from here. So to find the angle of elevation, we need to find this theta over here. This is 204 and it's 15. So obviously, if you make use of the tuakaso, then you will have tangent theta equals to the opposite over the opposite over adjacent. So therefore, theta is tangent inverse 15 over 204, which is 4.2 degrees 1 dp. And with that, that is the end of this entire session. Okay? Okay, so this is actually very rushed because I think I put in too many questions, but I hope that the questions are beneficial to y'all. Okay, I don't really get a lot of feedback from this session, so I don't know whether you guys understand or not. But if your opportunity, can feel free to share with me lah. Huh? Okay, so that is the end of the session. I will not waste too much time already. I will just quickly show y'all I'll just quickly close off this session lah. Okay, those want to go off, you can go off first. Thank you very much. For the rest of you, let me just leave this pause. Okay, hold on first. Okay, yes. So if got no other questions already, right? Maybe I just do a bit of closing. Not too important lah, but just close off a little bit. Okay. So I will just share with you guys that we are still open for students to join us for regular lessons lah. Okay. Of course, this is subject to availability and all that. So see you guys lah. Okay, so I'll just share with you guys the lessons, my lessons over here. So I teach Sec 4 E-Math at Tampines. So if got people in Tampines, you can come and find me at Tampines lah. It is on the Friday, 5 to 7 p.m. For the rest, you can look, if you're interested in other E-Math classes, you can come look for Teacher Clarence, Mr. Hassan, or Mr. Jason, right? Okay, does he take E-Math? Yes, he does. Okay. If not, then thank you very much. I will see y'all again soon. Okay. If there's any other questions, please let me know. Okay. Else, thank you very much.